During next 40 minutes, we'll make a rapid tour of CouchDB. First, we introduce me. So I'm Benoît Chenot. I founded a new company 3 years ago named NK Multimedia, the logo on top. I discovered CouchDB 3 years ago when working on a new project. I needed some new efficient way to store data. And I discovered CouchDB, and since I became one Apache CouchDB developers. Around CouchDB, I also maintain two libraries. CouchBeam, which is a library in Erlang that allows you to access to CouchDB, and CouchDB Kite, the same in Python. And I maintain also the CouchDB script, which is deployment of CouchDB in the embedded CouchDB application in CouchDB. So here it is. So why CouchDB? First, this is a document-oriented database. That means that you don't store only key value, you store documents with the key. CouchDB is HTTP native. We will see what it means. You can have your data local or on a centralized server. You can make P2P application with CouchDB, and it scales. Why it scales? Because of its infrastructure. CouchDB is written in Erlang. So it means that Erlang is a language designed to scale. You pass message between CPU or between machines. This is the same. CouchDB has an append file, only file structure. That means that when it says you that the document is saved, it's really saved. It's already on disk. Crash tolerance, because of that, because of Erlang, because of append file structure. This is HTTP. So first, what's document-oriented? Each document, each content in CouchDB is saved as a JSON document. You can see in this simple document that you have two members with an underscore. The ID is the ID of your document. This is a Unicode. By default, this is a UID in CouchDB, but it could be the key you want. And you have the rev member. The rev member is the revision of the document, but it's not recommended to use it as a history revision, because this is only for internal engine. It allows to CouchDB to detect conflicts between documents during replication and other data serialized that you can put in. So Jacob Kaplan-Moss, which is one leader of Django project, said CouchDB is built off the web. That means that CouchDB is built with an HTTP interface, but it is built to create HTTP application too. So the first thing when you install CouchDB and go on the URL, you install CouchDB, and the only mean to know if it's working is to go with your browser or curl to get to know if it works. So you get on the URL of your server, and it's a welcome, and it's version number. So it's web. What does it mean? HTTP is supported everywhere. If you develop in Java, if you develop in Python, if you develop in Ruby, whatever, each language has its own HTTP client. So there is a lot of tools and libraries. When you store a document with CouchDB, you do it via HTTP. In HTTP, you have 4 verbs: get, put, post, and delete. And each of these verbs are used to save documents or create database or do different actions in CouchDB. For example, to create a database, you just post to the server URL the name of the database in JSON, and your database is created. The same for your documents with put, post, and when you want to delete, you just send a delete verb to the server. Now, when you have once you have saved your documents on the CouchDB, you need to query them. CouchDB is based on MapReduce. This is a patent software concept that was developed by Google. CouchDB used its own implementation of the MapReduce system. That means that it's not patented. It is completely free, and it was checked recently by the Apache Foundation. So we use MapReduce to extract information from document. What does it mean? MapReduce is basically you have your document stored in the database. You do what we call a map. A map will get a list of your document. This list is composed of two elements. One is the key, and the other the value. So you get one list. And reduce is the mean to reduce this key value list in one list of values. I will see a concrete example just after. JavaScript is used internally to map documents and reduce them. Each map reduce function is done in JavaScript, and everything is stored in a specific document that we call the design doc. Each ID of a design doc starts with _design in lowercase. This is somehow like Lotus Note, where you have some design document to make a specific view of your data. When you want to query CouchDB, you have to query it on a specific URL on the view. A view could be a map or a map plus reduce. It's available at such URL. You will notice that every action on CouchDB for views, for CouchF, etc., will be behind the design doc namespace. So, what's MapReduce concretely? Here are documents that we store in a CouchDB database. The example is simple. We want to organize both on URL by people. So each people can put one, -1, or 0 to a new URL, and we want to get the top of URL. So we saved this document with value in the database, and now we want to map documents. We want to get all votes in the database. So a map is just a JavaScript function where you pass the document as argument, and here we map the document. We said that a vote is a document with an URL and a vote members. And we emit the URL as key. This is the first time of the emit function, and the value will be the vote. So we have the result at the bottom. It works, in fact, like it. Each time you save a document, nothing happens. But when you call your views, the document that you saved since the last time will be passed as argument to the function, and the function will emit values that will be indexed on the disk. So you get a list of results in JSON. First part of the view are the view information. You have the number of the rows in the views. Offset in case you have limited your views. And the result, as JSON, you have the ID of document mapped, the key, which is a URL here, and value, which is a vote. So we have a list of votes in the database. Now we want to reduce them to get the top. We want to calculate which value is attributed to an URL. So we make a reduce. Reduce is also a JavaScript function where CouchDB pass to it the keys that we retrieved before. Keys are URLs and the values. So two lists, each index is associated. Key 0 is the same as value 0. And we just sum all the values for a key. And then it reduces the previous list here to this list of two keys. So we have MySQL who have -1 votes and CouchDB that value 2. We can eventually reorder the view to get the results. So it was very easy to go from here, the list of documents, to our top of URL. Try the same in SQL or some other NoSQL system. It won't be so easy. So I just show the possibility to make views in JavaScript, but by in CouchDB you have also the view server design in your Erlang. So you can eventually make map reduce function in Erlang. But if you want, you can add your own view server and make it in Clojure, Scala, Java, Perl, whatever. Since CouchDB as a web server built-in and everything is just HTTP call, we also made the web admin self-hosted. Each CouchDB node has an admin, which is a web interface done in JavaScript. So in this admin, you could create the view, test your views, your map reduce, enter new docs, get the list of docs, make replication, etc. Deploy. So one thing that makes CouchDB different from other databases is the replication. We see what it is. Replication allows us to make easy failover, and we will see how it's easy to make a clustering of different CouchDB nodes. So first, replication. This is an incremental peer-to-peer replications. That means that when you there is no slave, there is no master in CouchDB replication. There is only masters. When you have a database and you want to replicate with another database, you just say post to the replicate URL of CouchDB and say which is the source, which is the target, and it could work in the other sense too. You could eventually make the CouchDB talk themselves in the same times from source from target. So you have replication in both sense. Replication could happen in a continuous fashion. You could make a one-shot replication between 2 nodes or 3 nodes, or you could make the replication continue. This is based on the change API of CouchDB. You can get all notifications from a database, the doc creation, doc saves, new design doc, etc. in real times, and the replication use it. With the replication, that means that you can take the data with you. This is very easy to install CouchDB on your own laptop. And since the replication is there is no master, no slave, and each node has its own history, you can just install your application on a laptop, take your laptop, put some data in your CouchDB, and when you come back online, just replicate to the centralized server, and data will appear on the web service or information system you use. So replication is incremental. That means that only new revision of document will be saved. So you could do simple replication between 2 nodes, or even more nodes. You can do the replication in both sense, or more. it works for all. Each time the replication is done, each time the history is updated, and you can replicate from A to B to C, whatever the sense you use, it will work. So the replication, an easy failover, you just have to create two machines, to install CouchDB on two machines, put continuous replication on one machine or the other, depends on which is online. And when a machine fails, the other will have the data in real time. Failover isn't enough. Obviously, you also need to mirror your data on maybe more nodes, and you want to be able to store more than 2 tier. Okay, with CouchDB database, when you have 500 megabytes on your gigabytes on your computer, you need obviously 1 terabytes on your hard disk to store the replication information and to store the B3 not compacted. So you may want to use a cluster. Designing a cluster is really easy. You can design your own if you want. That's what does Mibu. Mibu buys a cluster based on nginx and Twisted, a Python library. The define in short manner, each data is sharded. You define your shard at the beginning, and there is no named node or no masters for the replication. They have an algorithm that calculates the ID of the position of ID of your documents in the cluster, and so if one machine fail, you can still have access to your data. You will just have to put another machine in your shard, and it will recalculate the position of your document. So no master, no name node. That's not like Hadoop, where you have a single point of failure. Here you have none, except if your whole machine fails. This is simple HTTP. This is available not anymore on Google Codes, but now on GitHub. So this is with CouchDB. We just see the map read system, how to deploy your CouchDB nodes, and now we can do more. And so with a simple core, a CouchDB core, you can fetch your data, you can query your data, you can replicate your data. But obviously, sometimes you want to retrieve an HTML from your doc, or a PDF, or an XML, whatever. So you can take control of your data thanks to CouchApps. So here is an example. We take a doc, a list. Sorry. Here is a view result that we converted in HTML. How we do this? We simply create a function that will render the results of your view. Oh, that's not a view. Yeah, that's a doc. Here we have created a show, and the show just do one thing. It takes your doc ID. If the doc exists, it will continue the function, and it is rendered in HTML. You can also decide to render it in XML or JSON, or rewrite the JSON you want. There is no DB packed. This is cacheable. This is just HTTP. You have e-tags sent with your doc in HTTP headers, and so you can render in HTML or any formats. The same with result of the view. You have view results. Each row here is rendered in HTML via a list. List and shows are called in CouchDB server URL too. List have yet no impact on the database. They are run with one line at a time, so you can eventually stream the response. This is the same with the view. You can get the results streamed line by line in your application. So you can eventually get more than 10,000 lines in one time without taking memory on your application. And list can be rendered in HTML or in formats. When you save your documents on the database, you sometimes want to be sure that the user is authenticated, has the right to update a document, to delete a document, or even you want to make sure that the data is in the format you want. So for that, we have a validation function. Each validate function works on update. Each function is, again, a simple JavaScript function, which gets the doc, the user objects, and you can forbid return not found. You can raise HTTP errors to forbid an updated document. So CouchDB is provided with a lot of tools. We have tools to create couchapes, eventually with the show and list and other function bindings. You can bind embedded application, so no need to Python, no need to Java or anything else. You just install a browser and the CouchDB, bind your application, and it will be used by the user. Could also imagine auto update of application, improvement of application by your developers, and just simple replication of it on all your laptops. But when all these functions are not enough, you can extend CouchDB via the external HTTP handler and diamonds. What is an external? Oh, French. So, external are a simple script that you add to your configuration file. They just get a standard input, standard output from the system. In fact, CouchDB will send to your script made in Java, Perl, Python, Ruby, whatever. It will send a JSON. You read the JSON, and you send it back a string or another JSON to it to make action. So if you want to add a specific URL to get your image, transform them, resize them, and save them as attachment of your document. You create it in Python or Java or whatever. You add this script to your configuration files with the name of the URL, and CouchDB will send the HTTP put or post to your script and send back the response to CouchDB. Really easy. This is sorry. So that works for those who know, like WSGI or Rack in Ruby, which are HTTP gateway to Python for WSGI and Rack objects. And you don't need to have to manage how to span processes. CouchDB will span processes for you. It will create one process, and it will reuse it if needed. And under daemons and notifications, so you can add scripts to your CouchDB, but you can extend CouchDB with your own handler by the inherents. All parts of the CouchDB application are in the configuration file. So the view is one handler, the show is one another handler, Lists are another handlers. The way you see a database is another handler. So if you want to rewrite one handler of CouchDB, rewrite your own view system or add ones, like adding full text search, which is possible with CouchDB Listen, you can do it. Write your handler, add it to CouchDB, and it will be used as any other services in CouchDB. And if you want to do more, obviously, if you have a possibility to replicate your database so easily, you may want to create a real P2P web services. So why not adding Bonjour zeroconf to CouchDB? That's possible. In fact, some do this. You create your script, your daemon in Erlang, add it in the configuration file in the daemon section, and automatically CouchDB will handle it, will supervise it in case of failure for you, and it will work easily. You have notification. So you have two ways to have notification via a script that you register in your configuration file, via standard input as a standard output. That works like externals, or via the change HTTP handler I showed before. So some tools whereby it's like this. You have CouchDB Listen that allow instant full text search in your CouchDB node, or GeoCouch that allows spatial search in CouchDB. So like I said, you can create a standalone CouchDB application to make to have local data, make a peer-to-peer application. So to do that, I've written a script named CouchApp in Python. Each CouchApp is hosted in one design document, but obviously you won't have to tip in your HTTP interface the JIS and put the image via HTTP each time you want to create an application. So CouchApp is the process. You just create your structure on the file systems. There is one directory for views, one directory for shows, one directory for updates, and such. CouchApp script will generate this structure with generate commands. Then when you finish to design your application and want to test it, you just push to the DB like a Git or Mercure, whatever. And it will be available on CouchDB instantly. And if you want to replicate a remote CouchApp, it's possible too, thanks to the clone commands. The script is available on GitHub, and everyone use actually or recreate it in your own language to create CouchApps or design doc even. So here are some examples of CouchApps on top processing. An application that takes image and use the processing jQuery library to create effects on image. Here is an agenda that aims to work like the Google Calendar. It already works. You can add events, and thanks to the Change API, you can get update in real time in your own browser. Here are an example, another example at the bottom that works with Twitter. The Twitter client, classic website, Baylog. An information that is another that is Reddit-like. Difference with Reddit is that when someone added a URL or a comment or a vote, everyone that is connected on the information will get the information in real time. You can eventually do some Twitter-like, which is exists. It's called Toast. Or you can do a presentation application hosted on CouchDB. Each slide is a doc in CouchDB, and it's rendered via shows and list. So you could have CouchDB in your browser, or you could have CouchDB in your desktop too. Recently, Ubuntu, each Ubuntu has CouchDB inside, and a library they created, CouchDB desktop, allows you to write application using CouchDB on each Ubuntu. Ubuntu byte to the Ubuntu One services. You can pair your desktop with Ubuntu One services. On each Ubuntu One, there is a CouchDB. So you can eventually easily replicate the data from your CouchDB to Ubuntu One and using another computer and replicate it from Ubuntu One. Such things. You can even, thanks to Debus, pair 3 or more computers inside your network and share data between all the applications that work. It could be in your favorite OS too, since it's GPL. Arch Linux already under it. I think it will go soon in FreeBSD too. And future is CouchDB on your phone. Some people already ported CouchDB on the Nokia 9000. And some other have created API to simulate CouchDB via JavaScript on your phone. It's possible on iPhone, it's possible on Android, and thanks to HTML5, you can store locally the data on your browser, on your phone browser, and replicate to CouchDB. That's just HTTP. That's it. Future of CouchDB, there will be a permission management. It was recently committed in trunk. What it allows is to authenticate PeerDB. You can protect write, read, and such peer database. Native clustering. Native clustering will be solely used CloudEnd solution, which is another company that launched their services. This is a Giga cluster based on Dynamo concept. It works like React or Cassandra, same system of replication, and it's based on CouchDB. Improvement in CouchApps using CommonJS, which is a framework for server for JavaScript in server sites. We want to add it to CouchDB. And more improvement in HTTP and interface, maybe using web machine. We want to make sure that we are fully HTTP native to send the right message to you, etc. To go further, there is the CouchDB website. There is the books, which is available freely or on ORI. The CouchApp wiki, IRC, CouchDB.fr or CouchDB on Freenet, and that's it. Question? Sorry?
How performant you are is that it's going to be replicating a database that has attachment speed loss. And the second one, since we're seeing to allow partial replication of data today, I just want to replicate certain documents in a database to another one rather than put them all database.
Not sure to understand the second.
The second one is if I got documents 1, 2, 3, I just want to replicate document 2 to database 2.
If I understood well, well, the replication works in both sense. If there is conflicts,
No, I mean if it's foreseen to allow.
crossing to.
It's foreseen to allow.
J'entends pas.
Can you filter it, for example, only replicate out of your database?
So, j'entends pas. I don't hear, sorry.
Can you filter replication? So, for example, only replicate out of your
No, we can't yet replicate you can't yet filter the replication. There is in the change API, there is already a filter, and the replicator use the change So it's planned not for the next release, I think, but definitely for the 1.0, which will happen soon. Yeah. Yes. There is a revision member. Each document has a revision, which is used for replication. Each node keeps the history per documents, and when you replicate, each node sends the history. And CouchDB will try to find the last. And if there is a problem, if the target is one way behind your source, it will just raise conflict and let your application manage the conflict. Yeah. If you keep your laptop offline during 2 months, there is obviously conflicts, but this is your application. CouchDB won't do auto conflict repair. Thank you.